All right, good morning. Thank you to my sub for playing this video so that students can continue learning while I'm gone. Please get out your classwork packet and turn to classwork number 7. Um, you can hit pause so that students can do that. Thank you very much. All right, so we're saying these are your ACT and SAT scores. Sorry, we made this lesson when the SAT was still out of 800. Now they've gone back to the 1600 scale. So we're just going to pretend this was let's say a student 4 years ago had SAT scores and ACT scores of these. And what I want you to do is think about how can you compare the scores directly. So the ACT is out of, what is it, like 36, and this was out of 800. So they're on very different scales. So how do we compare them? Which score was the best? Which one was the worst? So what I want you to do is make a prediction. It's just a guess. Which one do you think was the lowest? Which one do you think was the highest? So go ahead and put those in order. So I'm going to say like 23 is the smallest maybe, and then I don't know. You want to put yours. If you don't think 23 is the smallest, that's fine. Adjust how you want to adjust, but go ahead and predict. We're going to come back to that later. All right, today our goal is using a z-table. Oh, I'm sorry. That's not true. That's tomorrow's goal. Today we're going to just look at the z-score. Tomorrow we'll look more at that table. Yeah. So by the end of class, every student will be able to use mean and standard deviation to determine the z-score. That is our objective. All right. Cool. Tonight's homework is homework number 7. I will have that sitting by the door. If you haven't picked it up yet, you'll need to get that. Okay. Here is last night's homework. So if you want to get that out, you can check your answers. In this case, the husband was paid better than the wife, and we kind of plotted that. What I chose to do is plotted it on a normal curve and just kind of looking at where did the data fall, which one was further from the mean. All right. Here we're looking at a probability, right? So what percent is below there? 2.5% or 0.025. Here, what percentage of women rank taller than 65? 50%, right? We're just looking at what percents on this normal curve. All right. Here, I know that we went 2 deviations. So 97.5. We're adding up is it between 8 and 8.5? Uh-oh, okay. Doubled it for single serving. The normal distribution is 8. Standard deviation of a quarter ounce. Suppose your serving weight is 8.5. What percent of servings are smaller than yours? Okay. So I went to 8.5. I took 50% and then added anything above 50% to get up to 8.5. I was wondering, why did I only write 2 things there? So I added those. I got 47.5 and then added 50 on because we were also included everything that was less than that 8.5. Okay. And the last one. All right, so if you have any questions about those, feel free to ask your neighbors real quickly or write down your question and I will answer it tomorrow when I get back. All right, so both ACT and SATs are designed to be normally distributed. All right, so the ACT mathematics section has a mean of 21 and a standard deviation of 5.3. So mean of 21, and I just did 2 deviations. On the next page here, this has a mean of 516 and a standard deviation of 116. So go ahead and do your couple deviations from the mean, and then it's asking you, predict the rankings of your test below. So now if we just look at a picture of it and we talk about what are the standard deviations, are you better able to predict what's the best score and what's the worst score by placing these scores from earlier onto that chart? So try that. Take a minute. If you want, hit pause so students can get their predictions in. Thank you. All right, so when we get all our numbers on there, not sure what that is. Oh, there's an extra curve. Oh, I see. Okay, so if we have, what if we have the same mean and the standard deviation? Sorry, this was a typo. All right, what if we have the same mean? So I want to take this and I want to take that and I want to put them together onto one normal curve. I'm going to have standard normal distribution, and that's where we get this 0, 1, 2, 3. 1, 2, 3. And what this 1, 2, 3 stands for is 1 deviation away from the mean, 2 deviations. So 1 above the mean, 2 above the mean, 3 above the mean. So here I could compare this 1 above the mean to this 1 above the mean. So if somebody scored a 26.3 here and a 632 here, because they're both 1 deviation above the mean, then they both did equally well compared to on either test, right? All right, so let's identify what a z-score is, and this is in your notes, so if you'll go ahead and write out what a z-score is. A z-score indicates how many standard deviations an element is from the mean. So the score we get with the z-score is going to be a number. We don't see many z-scores more than 3 or 4, and less than -3. So our table only goes from, let's see, -3.4 to +3.4, because those are very, very unusual. All right, how do you calculate a z-score? So the formula is here. It's also on your formula sheet, so it's not something you have to memorize, but you're going to use it so much, I hope you will. Z-score equals data point minus mean over standard deviation. I'm going to write that out in Greek letters. So the z-score is equal to data, so we're just going to say x is our data, minus the mean, minus mu, over sigma, our standard deviation. Data minus mean over standard deviation. So if you want to write that out, let's see how the formula sheet gives it to you. They give it to you in words. So data score minus mean, this is how you'll see it on your formula. All right, so what is the z-score for an ACT score of 23? Okay, so we need to know what was the mean and what was the standard deviation. And I believe it was 5.3. So the mean is 21. The standard deviation is 5.3. And our data point is the score that we're given. Okay, so we have all 3 parts. We just need to find our z-score. So we are going to say, all right, the z-score is equal to data point minus the mean, minus 21, over the standard deviation. Okay, so subtract those, we get 2 over 5.3. Type that in our calculator and see what we get. 2 divided by 5.3 is about 0.377. Now we're going to go to 2 points beyond the decimal, right? So the hundredths place. So I'm going to round that up to 0.38. 0.38. And we'll look at how to find that score on the z-table in the future. Well, tomorrow. All right. So what that means is, where am I on this chart? Well, it's not 1 deviation because we didn't get to 1 whole. It's less than half. So it's less than half. It's like maybe about right here. That's where that data point is. The score of a 23, right? This was 21. This was 26.3. My 23 is going to be about there. It's less than half of 1 deviation from the mean. All right. So what you want to do is calculate all the z-scores for the other tests. And we already just calculated this one, and we decided we're going to round it to 2 decimal places. So we can cover that up and say 0.38. So I'd like you to go ahead and calculate these. If you go ahead and hit pause on the video, these are the mean and standard deviation for the ACT and mean standard deviation for the SAT. All right, please hit pause. All right, I need you guys practicing and trying this. Thank you very much. All right, if you forgot to hit pause, go ahead and hit pause, rewind a little, make sure students are working these problems out before they see the answers. So here are the answers if you're all done. So what we found was a z-score for each one. Notice this one's negative. What that means is on this normal curve, here's the mean, that is below the mean, right? We're just a tiny bit below the mean. All right, so if we wanted to put them in order, we would say this would be the lowest because it's below the mean. This would be the next because it's a little bigger. It looks like this would be next, and this would be the largest, the highest score of all of them. That would be the highest. So it's easier to compare if we put them, if we standardize them, right? We put them in a format that we can compare them. All right, so let me check. This is on your classwork. I think it's on the next page. I'm gonna flip your page. Find the z-score for each of the following monthly costs given the mean monthly rent of $250 and standard deviation of $58. I don't know where this is that you can have rent for $250. Definitely not California. Maybe somewhere in the Midwest. All right. So, we are just going to practice. I'll do one more with you. To find the z-score, we're going to go data minus mean over standard deviation. Data minus mean, negative 50 over 58. We have to be very careful with our signs. 50 divided by 58, and I get negative 0.86 would be my z-score. All right, you guys keep going. So what I'd like you to do with these, I want you to go ahead, 1, 2, 3. There's 7 more. Go ahead and do them, and then compare them with your neighbors. Make sure you're good. If you have questions, you can ask each other or write them down for me tomorrow. All right, so go ahead. Hit pause if you could, please, so that students can work on this. All right. It looks like you have mostly finished up, so we're going to continue. Okay. Given that the mean hourly wage for workers at Panera is $12.50 with a standard deviation of 75 cents, find the z-score for each of the following hourly wages. Then plot them on the standardized curve below. So you don't have a curve below, so you're going to need to draw your own curve on your paper. All right, but go ahead and find them, and then let's locate where are they going to go. So $200, what is... Something's wrong with this. This problem is totally wrong. What happened? Okay, we're gonna scribble these out. Scribble them out with me. All right, let's come up with a couple hourly wages. All right, what if somebody made $10.50? What if somebody made $14.75? Somebody made $11.92 and $16.50. Oh, that's gonna be way high. Okay, so I want to know. That's gonna be hard to plot. Okay, let's say we'll just say $15. All right, so that'll be better. Let's go ahead and correct that, please. All right, so we're gonna take $10, just data minus mean. Data minus mean over standard deviation. Data minus mean over standard deviation. Data minus mean over standard deviation. Okay, so here we get $2 divided by 75 cents. Let's see what our z-score is. $2 divided by 75 cents. Need that 0.75. All right, 2.66. Uh-oh, what happened? 10 minus 12 would be a negative 2. All right, I thought something's wrong. If I get 2, it means that I must be above the mean, right? 2, so that's definitely not larger than 12. So I realized I must have done something wrong. 10 minus 12, we're going to get negative 2. So our z-score, the z-score is negative 2.66, which means it's below the mean. It's well below the mean. Negative 2.66 would be more than halfway. It's somewhere like right here. All right, it's well below the mean. All right. Okay, try these three and then plot them on a curve. Go ahead and hit pause if you're, so students can work. All right, hopefully that was enough time. I went and found all the z-scores. So my z-scores were here. So when I plot them here, it's less than 1 deviation from the mean. So it's like 0.7. So I would say that one is here. I could figure out what percent is below, right? We want to keep thinking about like what, we're here, but like what percent of the population is below me? All right, here 3, whoa, that is way up there, and 3.33, that is very unusual, would be somewhere over here, okay? So these are well above the mean and quite unusual. All right. 3 more problems. Oops. Okay. The mean score of the math section of the SAT is 518 with standard deviation of 115. Mean score of the reading on the SAT is 497 with a standard deviation of 109. Find the z-score of a person who scored 550 on math and find the z-score of a person who scored 550 on reading. Relative to the section, did this person do better on the math portion or the reading portion? All right, I want to give you guys time to think about this. Talk in your groups, discuss, figure out who did better. They did better on which section, the math or the reading? Go ahead and hit pause. Thanks. All right, so you've already figured this out. Notice I rounded to the hundredths place here. It looked like 487 or something like that, and I changed it to 49. All right, so here, relative to the section, who did better? Well, we can, as long as we standardize the score and find the z-score, we can compare them on the same, right, same grid. So here's 1 deviation above the mean. Here's like a third above, and here it's almost a half above. So who did better? Well, there's less people below. They did better than less people than here. So I would say they did better on their reading score than they did on their math relative to the test. They did better on their reading score. All right, and usually when you get tests, they give you the percentile, and they tell you what percent of people you did better or worse than, did better than. Yeah, so we're going to figure out how to do that tomorrow with the z-table. All right, because all of these, so empirical rule works when you're right on the standard deviation. If you're exactly 1 standard deviation above or exactly 2 above, it's easy. We can just add up all those numbers on that chart, right? On your formula sheet, you can just see all those percentages. But if you're not, if you're given a number, if you find a z-score that's between, that's when we need to use the z-table, which we'll look at tomorrow. All right, you guys have 2 more practice problems, so please try those, and I will see you tomorrow. Tonight's homework is homework number 7. You should have picked that up on your way in. Okay, thanks.